So Module 12 corresponds to Chapter 12 in the textbook, and it's all about farmland. We're going to go over characteristics of farmland, what makes it unique as compared to other assets, the value of farmland, and then analyzing land investments. So land is durable, it doesn't wear out. A tractor would be like another asset, but you use it in farming and then over time it wears out. But land, as you use it to farm, doesn't wear out normally. Now sometimes we can get it so that it has less nutrients in there and then it needs to be built back up. But in general, land doesn't wear out. It's immobile. We can't move it somewhere else, so its value is dependent upon its location. If we could move land physically to like downtown Salt Lake City, it would be worth a whole lot more. But because we can't move it to Salt Lake City, its value is dependent upon where it currently is. One method of valuing real estate is to use comparable properties that have sold recently. Those are also called comps. And this works better for houses because you can look in a neighborhood, and if you've had houses that have sold within a neighborhood, those are comparables, and so you can compare those to your house and determine what the value of your house is. Land typically doesn't have that many pieces that are sold in an area very often, and so there's few if any comparables, and so we can't use that method, and so instead we use something called a capitalization rate model. If there are comparables, they will use comparables, but often there aren't, so then they'll go to this cap rate model. This capitalization rate model is sometimes called a cap rate model. We use the perpetuity formula that we first saw in Chapter 9 and then again used in Chapter 11 with the retirement calculations. And it's the present value is equal to some type of an annual return, in this case the rental rate, what the land could lease for, divided by an interest rate. And I is the real rate of return because that rental rate is the real rate. And so the present value of the land would be just that rental rate divided by the interest rate. If your land is expected to grow faster than the inflation rate, then that amount that it's expected to grow faster is G, and you can subtract that from the interest rate on the denominator, and then that'll give you, again, your value. Present value is the value of your land today. We'll go through an example here. To use this capitalization rate model, suppose we have land that leases out for $300 per acre, and we desire a 5% real rate of return. So what is the value of our land? What we do is we take the $300, our lease rate, divided by the real cost of capital, 5%, and that's going to equal $6,000. 5% could be something different. We're just using 5% as an example. So if land is leasing or selling for more than $6,000, then it's probably not worth it. But if it's selling for less than $6,000, then the land is worth it. Another thing that we could do is if we expect the land to increase in value 5% a year, but inflation is only expected to increase 3% a year, the land's increasing in value faster than inflation, and that amount it's increasing faster than inflation is the growth rate. And so it's increasing 2% faster than the inflation rate, so your growth rate is 2%. So to find the value of the land, we take $300, our lease payment, divided by our 5% real rate of return, minus the 2% growth rate, and that's going to equal $10,000. So the land is worth $10,000, and that's more than that $6,000 because we factored in the value of the land, and it's based upon its annual returns, plus the values based upon expectations of that land appreciating value. And so together they make up $10,000. When you think about it, look at this formula, and I don't have a slide on it, but just kind of think through how are different factors going to affect this formula. If you have higher lease payments, what's that going to do to the value of your land? If you have higher growth rates, what's that going to do to the value of the land? If you have a lower or higher cost of capital, real cost of capital, what's it going to do to the value of your land? So you can think about just these different factors and how they're going to, because of this formula, factor into the land values. So to analyze farmland investments, the BIT does it with calculators and tables. And so it goes through some different cases that are more simplified with no taxes, no growth on appreciation, no debt financing, all those other things. We're going to use a spreadsheet and we're going to build total functionality into it for land appreciating values, taxes, debt financing, all of those things. And that corresponds to case 4 in the textbook. So that's what the worksheet that we build will correspond to an example like that. So the homework assignment is going to use the spreadsheet, but it'll change the assumptions. And so to build the spreadsheet, you'll modify what you did in chapter 10. And so there isn't a handout or an Excel file as a template for this one, because we're just going to take chapter 10s and modify it. And we'll go ahead and do that now.